All right, let's do our chapter 11 quick notes, our gold notes here to wrap up our chapter so we know everything we're responsible kind of for knowing. A lot of formulas this chapter, okay? And I give you some help on your tests and quizzes by giving you them in some format, but you really need to know which formula goes to which shape, and you need to know how to use it and how to find the given information. All right, so let's start here. A square, when we find perimeter, all of our sides are the same. So often if we call all of our sides S, we could just do 4 times S to get the perimeter. And then to get the area, we could do S squared. For a rectangle, the official formula for perimeter is 2 times the length plus 2 times the width. Or you add all the sides. It depends how your information is given. And your area, we can either do base times height, or you can also call it length times width. Okay, quick reminder, if you don't want to memorize anything for the square, that's fine, because everything for the rectangle will work for a square as well. You just find out that both sides, base and height are the same, or length and width are the same, whatever you're doing. Triangle, if I'm going to find the perimeter, I'm just going to add all the sides. Okay, there's no special formula for that one. And the area is 1/2 base times height. Okay, sometimes we write it base times height divided by 2. That's fine as long as we get that half or that divide by 2 in some way. Parallelogram, again, for the perimeter, we're going to add all the sides and make sure they're the outsides, all the sides on the edges. And the area is just base times height. It's super, super important to make sure the height is perpendicular to the base on both the triangle and the parallelogram. Okay, so always make sure the height comes from, usually in the parallelogram, it's inside. Okay, and make sure this height is in here compared to the base. They have to be perpendicular. Also in 11.1, we talked about if 2 or more shapes are glued together, you're going to add their areas. And if a shape is taken away from another shape, you're going to subtract their areas. Okay, so that kind of covers everything from 11.1. A lot of formulas. We practiced how to use them. All right, now when we go to 11.2, we have the trapezoid, which was 1/2 the height times base 1 plus base 2, and those bases are never the same. For the rhombus, we had 1/2 diagonal 1 times diagonal 2. And for the kite, we had 1/2 diagonal 1 times diagonal 2. Okay, quick reminder, whether you're dealing with a rhombus, okay, where all the sides are equal, whether you're dealing with a kite where 2 consecutive sides are equal, okay, either one of them, those diagonals in there are perpendicular in the middle, okay? So remember that those diagonals are perpendicular, because that's going to be big if you have to find one using like a squared, b squared, c squared, or a special triangle or something like that. Also remember that in a rhombus that the diagonals bisect each other, so these two are equal parts, and then these are equal parts going this way. And on a kite, only one pair of diagonals are bisected, okay? And it's a special note because it sometimes comes in really helpful. A square is a rhombus, so you can use that equation, 1/2 diagonal 1 times diagonal 2 for a square as well, okay? So just kind of a side note, and it really can help you on something. All right, then in 11.3, we started comparing similar polygons, and their side-to-side ratio is A to B, perimeter ratio is A to B. Those are the same. So once you have that ratio and you simplify it, I can't stress enough, simplify that ratio. The side ratio and the perimeter ratio are the same. The area ratio, you take your side or perimeter ratio and you square it, A squared over B squared. And if it was already simplified, it's still going to be simplified. If you're looking for a missing side or perimeter, you need to use the side or perimeter ratio. You have to use that ratio when you set up a proportion. If you're really finding a missing area, you have to use an area ratio. You can't use the side or perimeter ratio. So make sure you're using the right ratio for the shape, or the, not the shape so much as the dimension you're trying to find, whether it's a side, whether it's a perimeter, or whether it's an area. All right. That's what we took our first quiz over, 11.1 through 11.3. Then we came back in and we started on our circles, okay? 2 sections of circles, 11.4 and 11.5. I kind of grouped them together because they're so closely related in everything we did. Circumference is 2 times pi times r, or pi times diameter, okay? I'm going to tell you, if you have to memorize one, you go with the circumference equals 2 pi r. And remember, circumference is like the perimeter around a circle. It's the length. So to find the arc length, the easy way to do it is arc degree over 360 times 2 pi r. It's the part over the whole times that whole 2 pi r, okay? We also did arc degree over 360 equals arc length over the circumference, okay? If you're looking for something beyond the arc length, like if you're looking for one of the other missing things, the circumference or the arc degree, it's easier to set up that full proportion. Circle area is pi r squared. So when I find the sector area, it's still going to be arc degree over 360, the part over the whole, this time times pi r squared. So remember, the difference here is, are you looking for area or are you looking for length? With length, you go with the 2 pi r's. With area, you go with the pi r squareds. Remember, I'm going to give you formulas, but you need to know and pick and choose which one goes with which. Anything with pi goes with a circle. Anything squared goes with area, so the r squared is area. Anything that's just 2 times the r, or that is the circumference, okay? So remember those. And again, we could set this one up, arc degree over 360 equals sector area over the circle area, okay? And circle area can be replaced with pi r squared if you're solving for r or something like that. All right, let's flip it over and go to our favorite section, right? 11.6. I like that section anyways. All right, 11.6 is area of a regular polygon. And our formula is area equals 1/2 apothem times perimeter, okay? The question is, do you even know what those mean? A is the apothem. And remember, anything capital letters, like a P, means I do work for them. That's going to be the perimeter of the polygon. Okay, so if it's an octagon, you find the perimeter of the octagon. If it's a dodecagon, you find the perimeter of the dodecagon. Okay, so we always start, and the first question I always ask you is, what's the central angle? You always do 360 divided by n, however many sides they are. Then we draw our nice right triangle. On the top here, I always put half my central angle, okay? And remember, you just found that central angle by doing 360 divided by n. So whatever that number is, you take half of it and you put it at the top. If given a radius, it goes on the hypotenuse. The apothem that you're going to need, whether they give it to you or whether you have to find it, is this one right over here. Where's my pen? Why isn't it working? And then this bottom, and this is super important, is half of my side. So if needed, I use that to help find my perimeter. Okay. Quick reminder, for all regular polygons with a 30, 60, 90 triangle, that is a triangle or a hexagon, okay? And with a 45, 45, 90, that will be a square. This is super important. Your answers need to be left in simplified radical form because you are using those special triangles, okay? All right, then in 11.7, no new formulas. We just did probability, which means your possible chance on top over your total chances on the bottom. And remember, keep common measures the same. So length over length, area over area, perimeter over perimeter, something like that when you're finding geometric probability. And then always read carefully. Are you supposed to relieve it to the nearest decimal place? Are you supposed to put it as a percent? Are you supposed to put it as just a simplified fraction? So always read carefully there. Okay, I had extra room. I said, you know what? We're using a lot of our old notes. So I'll put it here on the same gold sheet so you can find it for quick reference. A lot of this, in fact, I think all of this comes from chapter 7. So if you want to find more detail, you go back to chapter 7. If two sides of a right triangle are known, you can use Pythagorean Theorem to find the third side. Pythagorean, it's an N, not an M. This is why I teach math and not English. Pythagorean Theorem. Okay, or remember that's a squared b squared c squared. Okay, so if you're missing one side and you know the other two, you can use Pythagorean Theorem. If you happen to have a 45, 45, 90 triangle, which we just said would happen in a square, your sides are the same on your legs and your hypotenuse is the side times radical 2. If you happen to have a 30, 60, 90, your short side is across from the 30, your doubled side is across from the 90, and across from the 60 is your x radical 3 side. And then don't forget, if you only know one side of a right triangle and an angle, then you can use SOHCAHTOA. All right, and so is opposite over hypotenuse. Cosine of the angle, whatever the angle is going to be adjacent over hypotenuse, and tangent will be opposite over adjacent, okay? You're not going to ever be looking for an angle on this one, so don't do the inverses. Just keep it sine, cosine, tangent on your calculator. Make sure your calculator's in degree mode, okay? This is just a quick thing, the things you need to know for Chapter 11. And then you take it and you apply it with the numbers given in the test, okay? Use this on your review pack. Use this to quick review for an exam, a test, so you know what was covered in Chapter 11, but really your knowledge is in the notes if you need to go more in depth, okay? Let me know if you have any questions.